Okay, so I'm going to talk through two examples of how to find the nth term of a quadratic sequence. So we've got the sequence 9, 18, 31, 48, 69 and 94. So anything we do with the sequence, really, we want to find the first difference. And I can see we're doing plus 9 plus 18 to 31 is 13. 31 to 48 is 17. 48 to 69 is 21. And 69 to 94 is 25. So now I can see that it's quadratic because this is plus 9, plus 13, plus 17, plus 21, plus 25. These numbers are going up by 4. So I can find the second difference. So that's plus 4, plus 4, plus 4, and plus 4. And what we do with this number, my second difference, is I need to divide it by 2 because this becomes the coefficient of n squared. So my coefficient of n squared means I've got 2n squared. And I got 2 because I did my second difference divided by 2. So my second difference was 4 and I halved it to get 2. So now I write out the sequence for 2n squared. So the sequence for 2n squared. So I'm going to try and line it up with the original sequence as well. So 1 squared is 1 times 2 is 2. 2 squared is 4 times 2 is 8. 3 squared is 9 times 2 is 18. 4 squared is 16 times 2 is 32. 5 squared times 2, so 5 squared is 25 times 2 is 50. And 6 squared is 36 times 2 is 72. So now I'm going to do a subtraction. I'm going to do my original sequence, take away the bit that I know I've got already. I already know I've got 2n squared in the sequence. We know that's part of the sequence. So I'm going to take away what I've found already to see what I'm going to be left with. So 9 take away 2 is 7. 18 take away 8 is 10. 31 take away 18 is 13. 48 take away 32 is 16. 69 take away 50 is 19. And 94 take away 72 is 22. Okay, so now this is the sequence I've been left with. And I can look and see that there's a pattern in this sequence as well. So plus 3, plus 3, plus 3, plus 3. So I'm now ignoring the rest of the question and finding the nth term for this sequence so far. So because it's plus 3, plus 3, plus 3, plus 3, plus 3, I've got 3n. And to find out what's at the end, I just work backwards and find what would have gone in that box. Something plus 3 makes 7. So I know in that box was 4. So I've got 3n plus 4. So I join those two bits together, my 2n squared and my 3n plus 4, and I find that the nth term of that quadratic sequence is 2n squared plus 3n plus 4. Now, if this is the part where you were getting stuck, this is just finding the nth term of a linear sequence, okay? So you need to look that up before you are happy. So we're going to move on and do another quadratic sequence. Okay, so this one here, just wait for it to stop being so blurry. So we're going to find my first difference. So plus 17 plus, to get from 7 to 4, we add 7, so plus 27 plus 37 plus 47 plus 57. Okay, and now I find my second difference is plus 10, plus 10, plus 10, plus 10. So I know I have my second difference, so I have 5n squared. And now I write out the sequence of 5n squared. So 1 squared is 1 times 5 is 5. 2 squared is 4 times 5 is 20. 3 squared is 9 times 5 is 45. 4 squared is 16 times 5 is 80. 5 squared is 25 times 5 is 125. Okay, and 6 squared is 36 times 5 is 180. So now I do my subtraction. So 0 take 5 is negative 5. 17 take 20 is negative 3. 44 take 45 is negative 1. 81 take 80 is 1. 128 take 125 is 3. 185 take away 180 is 5. So now I find the nth term of this sequence here. So we can see it's plus 2, plus 2, plus 2, plus 2, plus 2. So I know I've got 2n. And then I find the number that I would have had at the beginning. So something plus 2 makes negative 5. So I know that must be negative 7. So I finish it off with take 7. And then I join the two parts together. My 5n squared and my 2n take 7. So the nth term is 5n squared plus 2n take away 7.